Welcome to this explainer. We are jumping right into one of the absolute most profound conceptual shifts in human history. We're talking about our understanding of the very fabric of the universe itself. We're going to trace the evolution of mechanics, starting all the way back in antiquity, and watch how humanity's grasp of reality transforms from this rigid absolute stage into a completely dynamic, interwoven geometry. So, let's dive right in.
To start things off, I want to challenge your everyday, common-sense perception of reality. I mean, are space and time just an illusion? Most of us naturally perceive space as this sort of giant empty box that we just move around inside of. And time? Well, time is like an independent, universal ticking clock that never ever changes its pace. But what if those intuitive concepts are entirely wrong? What if the rigid box of space and the universal clock are just illusions?
To see how we got here, let's just trace this timeline chronologically really quick. Our understanding of motion definitely didn't happen overnight. It started with the ancient Greeks, right? Folks like Aristotle in the 4th century BC believed objects just naturally fell to their natural place. Fast forward to Archimedes and the lever. And then through the Middle Ages, where thinkers like Jean Buridan developed early concepts of impetus or momentum. But the real game changer happens when Galileo begins his quantitative experiments in the 16th and 17th centuries, rolling balls down inclined planes and actually proving uniform acceleration. All of this perfectly sets the stage for the scientific revolution.
And all of that incredible history leads directly to our first major era, the foundation, Newton's absolute universe.
In 1687, Newtonian mechanics literally changed the world. Newton brilliantly solved the mysteries of his time. He unified the laws governing an apple falling on Earth with the exact same laws governing the orbit of the moon. He established the law of universal gravitation. But to pull off this grand unification, he had to make some very specific assumptions. He treated space and time as completely separate entities. Time was absolute, ticking away totally independently of our consciousness. And motion, that required an absolute, unchanging frame of reference.
So the absolutely crucial point here is that for Newton, absolute space was a literal thing. It wasn't just some mathematical convenience. It was a theoretical frame of reference that existed completely independently of any objects or matter within it. It acted as the ultimate, immovable backdrop of the universe. It was a literal container. Newton knew he couldn't actually see this absolute space, but he firmly believed he could prove its existence.
But, in science, no paradigm lasts forever. Which brings us to the plot twist, the problem with absolute space.
Newton used a really famous thought experiment to back his claims. Step 1. A bucket of water is spun rapidly. Step 2. Centrifugal force pushes the water up the curved sides. And Step 3. Newton claims this proves absolute rotation relative to absolute space. He argued that because the water is moving relative to the bucket, the centrifugal force only appears because the water is rotating relative to invisible absolute space itself. Basically, the water somehow just knows it's spinning.
But hold on a second. What if the bucket is still and the entire sphere of fixed stars rotates around it? Enter the ultimate skeptic, 19th century philosopher and physicist Ernst Mach. He wasn't satisfied with this invisible absolute space idea at all. He used a brilliant variation technique, completely flipping the script. Wouldn't we see the exact same centrifugal forces appear in the water if the rest of the universe spun rapidly around a completely still bucket?
Mach drives this home with a profound point, stating no one is competent to say how the experiment would turn out if the size of the vessel increased in thickness and mass till they were ultimately several leagues thick. What Mach is doing here is pointing out that the inertia we feel, that literal force pushing the water up the sides, might not be an interaction with some invisible, empty, absolute space. Actually, it might be a physical interaction with all the other massive bodies out there in the universe.
This gives us what Einstein would later name Mach's principle. It's the hypothesis that the inertial properties of a body are determined by the presence and distribution of all other matter in the universe. Think about that for a second. It's the mind-blowing realization that the inertia you feel when you accelerate in your car or the centrifugal force on a spinning carnival ride might actually be the result of a physical interaction with all the distant stars and galaxies. Without the rest of the matter in the universe, an object might not have any inertia at all. No way, right?
That exact profound philosophical skepticism sets the stage perfectly for our final act, the climax, Einstein's relativistic reality.
When we compare Newtonian versus relativistic mechanics, the contrast is stark.
The old Newtonian mechanics demanded absolute time and space, separate entities, and invariant inertial frames, with gravity as just this invisible force. But Einstein realizes that space and time are absolutely not a fixed stage. They are a flexible, interwoven fabric, space-time. Your measurement of time and space completely depends on your relative frame of reference. And gravity? It's no longer an invisible force pulling across a static void. It's the actual geometric curvature of that interwoven fabric.
A major stepping stone for Einstein to get there was linking inertia and gravity, which he formalized with the equivalence principle. It states that an observer cannot distinguish between a uniform acceleration in an empty region of space and being at rest in a uniform gravitational field. Imagine you're in a completely enclosed box. Einstein realized that if that box is accelerating uniformly through empty space, the physics you experience inside are totally indistinguishable from what you'd experience if the box was sitting completely still in a uniform gravitational field. Falling freely in gravity is exactly equivalent to floating smoothly in empty space.
This whole relativistic worldview gets beautifully formalized mathematically as Minkowski spacetime. You have the absolute future, the absolute past, and the hypersurface of the present. Imagine a cosmic speed limit, bounded by the speed of light. That vertex right in the middle, that's you, right now. Everything inside the bottom cone is your absolute past, events that could have reached you. The top cone is your absolute future, stuff you can still influence. And that flat plane slicing right through the middle, that is the hypersurface of the present. But here's the kicker. Because time is relative, observers moving at different speeds will literally have entirely different slices of what they consider to be now.
Finally, everything culminates here with the general theory of relativity in 1916. This monumental theory entirely replaces Newton's law of gravitation. It successfully incorporates Mach's relational philosophy into spacetime, proving that local physics is determined by the large-scale universe, because the very curvature of spacetime is dictated by the matter and radiation within it. Inertia and gravity are intimately linked because they are both simply expressions of objects moving along the simplest path through curved, four-dimensional geometry. The universe is no longer an empty box. It is an active, flexible participant in every single event happening within it.
So as we wrap up this explainer, I've got to leave you with this one provocative question. Over 2,000 years of mechanics led us from Earth-centered models to Newton's invisible clockwork stage, and finally to Einstein's curved spacetime, where distant stars literally dictate your local inertia. If space and time are just flexible relationships shaped by the mass of the universe around us, what else about our everyday common sense reality is an illusion, just waiting for the next paradigm shift? Thanks for exploring this with me.